So in question 3 we have this weightless seesaw. It's at rest with a girl of mass m sitting on one end. We'll have her height as 0. And then the girl's older sister of mass 2m sits on the other end 1 meter above the ground. So the height initially is 1. Find the speed with which it hits the ground, so going down this way. Okay, so let's look at potential energy and kinetic energy for both of these. So initially, if we take m, for potential energy, mgh, and it's leaving from rest a half m by v squared. The 2m initially is m 2m gh, 1 above the ground, and starting from rest a half m by v squared. So the total energy in the system at the beginning is just 2mg. All of these equal to 2mg. Then it starts moving and hits the ground. So let's do it in blue. M becomes up here, so m is 1 above the ground. So we have mg by 1. We don't know its speed, a half mv squared. 2m is now on the ground, so m 2m by g by 0, and a half 2m v squared. So the total energy in the system now is mg plus a half mv squared, and mv squared is 3mv squared over 2. Has to be equal to the original energy, 2mg. So if we bring mg to the right, well, let's divide by m first. We're going to get just g, 3v squared over 2 is equal to g. So v squared is equal to 2g over 3. So v would have to be equal to the square root of 2g over 3. Don't think it asks for a decimal, does it? Speed at which it hits the ground, square root of 2g over 3. Let's have a look at this skydiver of mass m jumping out of an airplane. So there's a force going down. Force going down is mg. And he reaches terminal velocity, his speed 28. So there's a force, air resistance is mkv, it's going in this way. Air resistance is mkv, so I think this is force up equals force down, or force down equals force up. So mg is equal to mkv, mk by 28. So we're going to get k is equal to g, which is 9.8. K is none of the real numbers, 9.8 over 28. K is equal to 98 over 280. Both of those divide by 14. K is equal to 7 over 20, which is equal to 0.35 for the air is now the speed. We're just asked to find k, just k. Here we have question 4. It asks you to define momentum. The product of mass and velocity is momentum. So this m1v1 plus m2v2 is involved in this question is equal to m1v2 plus m2. And I'm putting v's instead of u's. m1u1, m2u2, m1v1 plus m2v2. A lot of m's and v's. Okay. A bullet of mass 5 grams. So we have 0.005 in terms of kilos. Fired horizontally with speed of 200. Enters a block which rests, so it's at rest, so we have a speed of 0. So plus 1 by 0. That's going to be equal to, does it embed? No, part 2 is embeds. It emerges from the block, so 0.005 at a speed of 100 plus 1 times v2. I'll just call it v. So 200 by 0.005, 0.5 by 2 is 1, is equal to 0.5 plus v2, if you want to call it v2 too. So just v, the speed of the block is just 0.5 meters a second. Then if it becomes embedded in the block, well, if it becomes embedded in the block, the speed here is going to be the same. So the mass is just going to be 1 and the 0.005 for the total mass. So we're going to get again 0.005 by 200 will be equal to 1.005 times my v. So 1 on the left divided by the 1.005 on the right will be the speed of the combined bullet and block. And this is giving me 0.995, corrected 3 decimals, meters per second. Straightforward enough question number 4.